Hi students, let us try to understand the resistance of a system and resistor. So when you are talking about the resistance of the system, friend, here let us try to read out the NCERT book. In preceding section, we learn about some simple electric circuit. We have noticed how the current through a conductor depends upon its resistance and the potential difference records its end. In various electrical gadgets, we often use resistors in various combinations. We now therefore intend to see how Ohm's law can be applied to combination of resistors. There are two methods of joining the resistors together. Figure 12.6 show an electric circuit in which three resistors have resistance R1, R2, R3 respectively are joined end to end. Here the resistors are said to be connected in series. Resistors are said to be connected in series. So resistors are there R1, R2, R3 are the connected in the series. They will decrease the current. Okay, so figure 12 point show the combination of resistors in which three resistors are connected together between the point X and Y. Here the resistors are set to connect in the parallel. So R1, R2, R3 they are in the parallel line. What is meaning of resistor in series? What happened to the value of the current when the number of resistors are connected in series in a circuit? What would be their equivalent resistance? Let us try to understand these with the help of the following activity. Okay, so here see 12.4. Join three resistors of different value series, connected them with the battery and a meter, plug a key shown in figure. You may use the resistor of value 1 ohm, 2 ohm, 3 ohm, etc. and the battery of 6 volt. Performing this activity, plug the key, note the meter reading. Change the position of a meter to anywhere in between the resistors. Note the meter reading each time. Do you find any change in the value of the current through the meter? So if you see here, friend, you will observe that the value of current in the meter is same uh, in depend on of its position in the electric current. It means that in the series combination of resistors, the current is same in every part of the circuit of the same current through the each resistor. So it is series, so everywhere you will find the same current. But what is happening in the parallel line? Let us do the activity 12.4. In activity 12.4, insert a voltmeter, record the x and y of the series combination of these three resistors as shown in figure 12.6. Plug the key in the circuit and note the voltmeter reading. It gives the potential difference across the series combination of resistor. Let it be V. Now measure the potential difference across the two terminal of the battery. Compare the two value. Take out the plug key and disconnect the voltmeter. Now insert the voltmeter across the end X and P of the first resistor as shown in figure 12.8. So these are there. R1, R2, R3 are there. Okay. Plug the key and measure the potential difference across the first resistance. And okay. So they are saying the plug the key and see what is happening. Similarly, measured of the potential difference across the other two resistance separately. Let us value V2, V3 respectively. Deduce the relationship between V1, V2, V3. Okay, you will observe that the potential difference V is equal to sum of the potential difference V1, V2, V3. That is the total potential difference across the combination of resistors in a series is equal to sum of the potential difference across the individual resistance. So V is equal to V1, V2, V3. In the electric circuit shown in figure 12.8, let I be the current through the circuit. The current through each resistor is also I. Is possible to replace the three resistors joined in series by an equivalent single resistors of resistance R, such that the potential difference be across it and the current I through the circuit remain the same. Applying the Ohm's law to the entire circuit, V is equal to IR. And applying Ohm laws to three resistors separately, we further V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. From equation IR is equal to IR1 plus IR2 plus IR3. So R is equal to what? R1 plus R2 plus, which conclude that when the several resistors join in series, the resistance of the combinations Rs equal to sum of the individual resistance R1, R2, R3, and thus greater than the individual resistors. Now let us let us try to perform the problem based on it, friend. What the problem? Okay, we'll do the problem later on in the video. Thank you so much for watching.